Okay, so how do we do this? What do you think we should do on this first one here, on 18Z? Okay, and there's also a systematic way of doing these guys. So it doesn't have to be like trying to figure out the perfect roots and stuff. You can just put 18 on a factor tree and break it apart, and you want the smallest number that can possibly go into 18 on the left. So you don't do six and three, because there's a smaller number that can go into 18, and it should and 2 and 9, and that 2 should go on the left. So put 2 here and 9 here, and then break this down to 3 and 3. Okay, and what you do is you want to circle your pairs. Circle your pairs. There's the one that's by itself. Okay, from your pairs, scratch out one of your pairs. That one gets out of jail. The one that's by itself stays in jail. So there it is, in jail. And as far as the variable goes, you could do like, let's just talk about like the square root of z to the 10th power. And when you have here, I'm gonna make a different letter in case you ever look at this work and you're like, what the heck, z to 10, w to 10th power. Okay, and when you're doing square roots, there's actually like an invisible 2 right here. It's implied. If you're doing cubed roots, then it'll show you the 3 right there. All right, so what this means is it's w times 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 w. 1, 2, 3, 4, 5, 6, 7, 8, 9. Squeeze it in there. Times w. And for every pair of w's you have, you cross one out, one goes out of jail. Cross one out, one goes out of jail. Like this. Okay, and so if that was the case, you have 5 w's out of jail, so that would be just w to the 5th power. If you had an extra w, like a remainder one, then it would be root w. A faster way of doing it is just going like this and dividing the 10 over here by 2. Alright, so in your head, 10 divided by 2 is 5. The answer is w to the 5th power. You see? So but if it was like, let's say it was the square root of w to the 7. Well, you divide the 7 by 2, what do you get? With remainders. What do you get with remainders? With remainders. Wait, we have a 2 right here, right? So 7. So wait, so if we're doing it like 2 going into 7, right? It's 3 remainder, and then 2 times 3 is 6, one more extra to get you to 7. So the remainder is 1. Okay? That remainder is what stays in the root. So this becomes w. How many times did 2 go into 7? 3. 3, there's your 3. And then your remainder, there's your remainder right there. There's your remainder of 1. So so here's 3 times, wait, 3, remainder 1. There's that 1. There's that 3. There's that 3. So it's w to the 3rd, right? Okay, so then this problem here, you don't have any other w's. I mean, any other z's. So that z is going to have to stay in the root. Okay, so we dealt with the 18. The 18 is 3 root 2, and you can't do anything with the z. So there it is. So that's your answer. The whole thing comes out. You mean like m to the z to the 9? Oh no, z to the 9. I see what you're saying. Wait, that's not a perfect square. Well, it's okay. So you're talking about like how would you deal with like w to the 9, right? Okay. Yes, and you're gonna find out right because you have w times 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 w. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so here's the pairs. And this really, the reason why 1 comes out is because this is w squared. And what is the square root of w squared? W. So I just think of it as by 1, 1 comes out. All right, and then here, 1 comes out. So gone. 1 comes out. 1 comes out. And look, there's your remainder. So it's not the same as taking the square root of 9. This is different. Okay, so you got to have the 2 here, you want to divide it out. And you're going to find that it goes into it 4 times. So it's going to be w to the 4th, and then since you have a remainder of 1, you have 1 w left over. That's how you deal with that. Yes. Correct. You treat it like you're dividing it on the variables. Only when we're talking about variables. Okay. Then it would be if you had 45 to the 9th like that, or 45 to the, I would probably, there's like different ways of doing this, but I would do let's see, what's the way to do this? You could it would do, this is the same thing as 9 times 5 to the 9th, right? So you have that 9 times. Like, so you have 9 nines. I can go like this: 9 times 5 times 9 times 5, 9 times, right? Or I could do 9 times 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 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5. 6, 7, 8, 9. For every pair you have, 1 comes out. For every pair you have, 1 comes out. For every pair, you can do it like that. That's one way to do it. Yeah, you can. You mean get like a monster number, 45 to the 9th? You could. You're not gonna be asked to do that. So I wouldn't worry about it. The problems will look more like these guys. They'll be like low numbers. So here, so let's talk about 45m to the 7th. 45m to the 7th, or root 45m to the 7th. All right, hold on. I want to put you on pause for a sec. Hold on a sec. We're zooming. All right, so this 45, just go ahead and you can factor tree the 45. Okay, then what? Then 3 and 3, okay. 1 escapes, bam, and 1's actually left in prison. What about me? Okay, and then what do we do? How do we deal with that 7 right there? So divided by 2, so that means, I'm going to rewrite over here, you have your 3, and then you have your m, and what was divided by 2, what do you get? So 3 outcome, and then your remainder, don't forget your 5, and your remainder is right there, which you don't have to have that 1 right there. And then don't think that this 3 belongs to the root, it belongs to the m. I put them kind of close together. Like that. Hold on a second.